it does intersect, but the question is what percentage of the open space is accessible? And so in this context, what we'd be saying is, if you're within the buffer, you're accessible from the road, right? So that would imply then this is an intersect situation. So what we're going to do is we're going to basically carve out the pieces of the open space that fall within the buffer, right? So then we'd be using, again, a geoprocessing function. In this case, what we do is we clip, or we could do intersect, but we only want the pieces of the open space. We don't really care about the road buffer itself. So we basically would be clipping the parks or the open space, and we'd be using this road buffer as the clip cookie cutter, and this will carve out or punch out those pieces of the park that fall within the buffer, and it'll create a new layer, right? So we'd say park buff clip, something that's recognizable, and when we do that, we'll end up with a very small thing. Let me make it brighter. So you see those pieces are the things that fall within the buffer. So now, if we were looking at that, we could say, okay, well, how much is that, right? And so it's got a lot of pieces to it. It's actually kind of a complex polygon, and that's okay. But we want to know is how much area is it. And it tells us by default, but I want to add a field in here to calculate the acreage of it to make it comparable. So I'm just going to add a quick thing, and I'm going to right-click and use the calculate geometry to figure out the area in terms of acres. All right. Now, I take the statistics from that, and I say, okay, there's 157 acres that were clipped out by that buffer. So 157 divided by 844, I think is what. So about 19% of it is accessible from the road, if we take that range of proximity to be close enough. So already two different measures of accessibility. We've got a global statistic about the rate of number of acres per 1,000 people. We have a buffered approach to identify things that fall within a particular area of that. We could also use the other direction too. So that's kind of the road question. Another way of looking at this would be to kind of be more granular about about distance. So one way of being more granular would be, rather than using this buffered approach, we'd use a raster approach to create what's called a distance surface. So we could actually break down incrementally distances away from these from the open space. So what that means then is we're going to basically create a raster for the whole town with all the cells occupied by the distance to the nearest open space. So in this case, what that means is that we have, if you have a polygon that represents open space, we're going to know the distance going out in all directions from that. And that surface that covers the whole town will be classified in a grid of squares, where each square says how far are you from the nearest open space. So what's nice about that is that once you have something like that, you can summarize it by any unit that you're interested in. So let me just walk through what I'm talking about here. So to do this, we'll need to have the spatial analyst extension turned on. So under the customize button, or customize option, we'll want to go to the extensions and turn on the spatial analyst first. And once we have that, then we're going to open up our toolbox. And in that toolbox, you have a spatial analyst tool set. So the spatial analyst tools, you expand that. One of the things that you have in there, many tools, is this distance tool. And so in the distance tool, the thing that we're interested in here is called the Euclidean distance. And Euclidean just means that it's a two-dimensional distance. It doesn't take topography or three-dimensionality into account. So if we initiate the Euclidean distance option, it's going to ask, well, what are we calculating distance from? That's the first item. So this, in this case, we're actually going from the parks, because we want to know how far we are from parks. It's going to generate a distance raster, and I'm actually, in this case, going to let it go to its default, which is fine. And it wants to know how big a cell size, so this is kind of the resolution of the resulting image. So this is going to be in the units of whatever the projection is. So this is mass state plane, all the stuff in Mass.js, so it's going to be in meters. So I'm going to make it 10 meters just to make it a nice round number, and it's probably not too bad a resolution for this scale. Now, when I do raster analyses in particular, it's very important you control the environment that you're working. So you may have noticed in other tools you use, there's always this environments button. And when you click on that, what it does is it gives you control over how this tool will behave. And so in this case, we don't want the raster to go off into the wild blue yonder. We want it to stop and stay within the town. So what we can do is we can set it so that the processing extent is coincident with the layer of interest. So in this case, I'm making Angusberry be the processing extent. And so what that'll do is it kind of confines the analysis to just that extent of that polygon rather than going off too far out. So there's other values in here too that you can use if you do work with rasters, like in particular whether you want to use a mask to kind of confine it. But in this case, the processing extent is adequate for what we're trying to do here. So I just said okay, you're just setting that parameter, and that parameter is only active when you're using this tool. It's not a universal parameter that you've set. You can actually do it universally if you want to, but it's, you've got to remember that you did that, because then you might leave it there. So in any case, I've basically chosen the thing we're measuring from, the output location, cell size, and I specified the processing extent and the environments. So then I hit OK, and what it'll do is it'll slowly work through and calculating this distance, and so what you end up with is this thing. And so what this is it's all the cells in the raster represent values that indicate how far they are from the nearest open space. So you can see that the yellows are closest to the open space edge, and then as you move outward, the distance increases. And the nice thing is that you can control like the fineness of the representation with that, and through the symbology, instead of doing classified, you can do stretched that would capture that in kind of finer distinction, these kind of clouds of distance. Now you say, well, what's the use of that? I mean, how would you use that? Well, I won't do it because it's going to just take too much time at this point. But you can actually figure out, like, for example, let's just pretend, to make it simpler, that this was like a census unit or a house or something like that, polygon. You can summarize essentially the average distance for that polygon for all the cells that it falls on top of. So we could have all of the polygons of census units, blocks, or anything, and each one would get an average value. And so you could say, on average, this is how far people are in that block unit from the nearest open space. And it's kind of like as the crow flies, kind of nearness. It's not, right? So the Euclidean distance surface is nice because you get these fine-grained things, whereas a buffer, you have to specify how far. But the other thing, too, is that you could actually even classify the roads in terms of how far every single road segment is on average from the nearest open space, too, to get a sense of how that varies across that surface. So it's partly visualization, but also partly calculable. And so if you wanted to do that, and I won't do it now, but we can talk about it later if you're curious about this, is there's this zonal tool that allows you to calculate the zonal stats table, and that's the one that you say, okay, I want you to summarize for me the average distance or value for all of my road segments or my polygons or whatever, and it uses this tool. So you get a nice breakdown of what's happening in your data set. Okay. So now we've got 3 different ways of measuring it. One more. Okay. I'm going to show you real quick, just because I'm going to drag you through this. And that's using, taking into account that we don't travel in straight line distances because of, as crow flies